Keenly, and we're excited to talk to you today about Smartparkuipad. Now, anyone who has ever driven has had difficulty finding a place to park. Whether it's work, meetings, class, we've all been late driving circles around the lot, going up and down the aisles, looking for a spot that simply isn't there. And on campuses with multiple lots, such as UNH, you may have to drive across campus to find a lot that you can actually park in. This causes traffic congestion, it's a waste of gas, but most importantly, it's a waste of your time. The solution is a parking monitoring service that gives real-time lot occupancy to commuters so they know exactly where the open spots are on campus so they quickly and efficiently get to their final location. We've had support from UNH officials such as the Assistant Business Director of Affairs, David May, Dirk Timmons, who is the Director of Transportation, and Jeff Parsons, Parking Manager, along with other parking officials, who are extremely interested in working with us and developing a solution to this perceived parking problem. In our presentation, we're going to cover the market, which of these crowded campuses that are continuing to grow and continually having parking problem needs, and how we focus on on campuses with multiple lots and managing them in real time. We'll give an overview of the system and how parking management has evolved, and talk about how our flexibility in financing allows us to be an effective measure for many universities and dealing with smaller and larger schools and really serving their needs. So each campus has different needs. There are some small campuses like UNH which continuously are growing, removing parking from the center of campus to build academic buildings and residential buildings, pushing the parking to the outskirts. There are also campuses like University of Buffalo with multiple campuses in an area which students have to drive from one location to the other, meaning they need to know lot occupancy several times a day. Along with commuter schools, which every single one of their students is driving in, and they have lots of parking problems in key points of the day and need to change behavior to make a more efficient system. The solution to all of these problems is a parking monitoring app. By making the information available in real time, commuters will know exactly where the open spots are and get there directly, decreasing through traffic and decreasing commute time to get to their final location. We also will have analytical tools which serve to benefit universities, so as they continue to evolve and change the campus, they can identify parking problems, best make the transition to more walker-friendly campuses, and really best serve the community. But it's not just important to have a good idea and have the technology to back it up, but a system in place to get it into the final hands of users, and this all begins with understanding the sales cycle and how it has to work with the university budget system. Understanding that we have to get in with the transportation department in November, December, get on a final contract in July, and hitting the developing network and implementing it by the middle of August to hit the fall semester. On the flip side of that, we have a sales cycle with private companies, which will again start in August, budgeted in December, and be implemented in April. And I will pass off to Matt to talk more about our technology.
Thanks, Ethan. So the Smartparkuipad system utilizes Earth's magnetic field. When you take a large piece of ferrous material, such as the metal that's in a car, you pass it through that field changes slightly, and it's that change in field that our sensor realizes. And when that realization is made, slide please, the information is wirelessly transmitted from the field sensor to a base station that is connected to the internet. That information is then transmitted over the internet ultimately to cloud storage with a database, to the SmartParkU website, and to a SmartParkU smartphone application. In our development cycle right now, we're currently moving out of Phase 1 and into Phase 2. In Phase 1, very happy to say that we were able to create a prototype that's able to sense a car, to transmit that information wirelessly, and to publish it on the internet on a desktop server. In Phase 2, what we're really looking to do is to create a field-ready design that has better packaging so that it can bear the elements of New England, to better optimize our code so that we have better power consumption and better data transmission. And then in Phase 3, what we want to do is implement a database and have the website and smartphone application talking to the database and pulling that information so that students can receive that information in real time. And in Phase 4, we plan on field testing our units. And those field tests will be happening at UNH. David May, who Ethan just talked about, said that they would be interested in helping us field test the units around UNH. Slide. What you're seeing right here is a proof of concept video of our design. We have the SmartParkU sensor that's positioned outside of Kingsbury Hall. When a car drives by, the LED lights up. That's indicating that it's sensing the car, that data is being transmitted wirelessly to our desktop server. It indicates that a device has been connected at a specific time and IP address. Then it provides the number of cars that are passing by the sensor and a time since the sensor's been turned on. In terms of our competition for SmartParkU, we've identified 3 companies that are currently in the market that are doing similar things, but not exactly what we plan on doing. Mobile Parking Apps works with municipalities to help citizens find parking in cities. Thrifty Airport Parking does parking management at airports and airport garages. And NZCMS is a company that does lot management by using gates and ticket systems. What I'm going to do now is turn it over to Jeremy to talk about our financials.
Thanks, Matt. So you're asking how we make money. Well, we have 3 contract types. They are upfront, biannually, and monthly. And then we also have 2 cost structures. So the cost structure for schools over 6,500 undergraduates is $6 per student per year. Then we also have a small school, which is under the 6,500 threshold, and it's also corporate structure, so that structure is per lot, per equipment basis. So then our startup costs, we've need to design the app some more, get the sensors working, get the network up and running, develop the analytic tools, get through all the stages of development that Matt told you about. We've calculated these costs at $130 for $1,000, and our average burn rate we've calculated to be $2,400 per month for the first year. So we break even in about year 2.5. We've calculated this pretty conservatively, as you'd imagine. Our expenditures, we've kept them very conservative by not accounting for economies of scale with our sensor costs, which will go down dramatically. And we've also kept replacement costs in there. So say when a contract runs out, we've calculated that all the sensing equipment would need to be replaced, which we do not believe to be true. And so that will drive down expenditures. So SmartParkU is really looking forward to developing our network, getting all the things we said we want to do, developing the app, and working with investors, campuses, and commuters to help them reach their destination.
Any questions?
Cut.